Black holes are among the most fascinating objects in the universe. They captivate scientists and enthusiasts alike with their mysterious nature. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. The event horizon marks the boundary beyond which nothing can return. They're incredibly dense objects, with masses many times greater than our Sun. Black holes represent the most extreme manifestation of space-time curvature. The most common way black holes form is through the death of massive stars. These cosmic giants live out their lives in a delicate balance, constantly battling the forces within them. Stars are giant balls of hot gas held together by their own gravity. They shine brightly for millions or even billions of years, illuminating the cosmos with their radiant energy. They produce energy through nuclear fusion in their cores, creating outward pressure that balances the inward pull of gravity. This fusion process converts hydrogen into helium, releasing immense amounts of energy. When a massive star runs out of fuel, it can no longer support itself against its own gravity. The nuclear reactions slow down, and the star begins to cool and dim, signaling the end of its life cycle. The core collapses inward, and the star's outer layers are ejected into space in a spectacular explosion known as a supernova. This explosion is so powerful that it can outshine entire galaxies for a brief period. If the core of the star is massive enough, at least 3 times the mass of our Sun, the collapse continues indefinitely. The core's gravity becomes so strong that not even light can escape its pull. The core shrinks to a point of infinite density called a singularity. This singularity is a region where the laws of physics as we know them break down. This singularity, shrouded by an event horizon, marks the birth of a black hole. The event horizon is the boundary beyond which nothing can return, making the black hole an enigmatic and fascinating object in the universe. Black holes come in a range of sizes. Stellar mass black holes, as their name suggests, are formed from the collapse of individual stars. They typically have masses a few times greater than the Sun. Supermassive black holes, on the other hand, are millions or even billions of times more massive than our Sun. They reside at the centers of most galaxies, including our own Milky Way. The formation process of supermassive black holes is still not fully understood. They may form through the mergers of smaller black holes or the direct collapse of massive gas clouds in the early universe. The event horizon is the defining feature of a black hole. It is the boundary beyond which nothing, not even light, can escape the black hole's gravitational pull. Once something crosses the event horizon, it is destined to fall into the singularity. The singularity is the point at the center of a black hole, where all matter is compressed into an infinitely small and dense point. It is a place where the laws of physics as we know them break down. Supermassive black holes play a crucial role in the evolution of galaxies. These enigmatic objects, with masses millions to billions of times that of our Sun, are not just passive observers in the cosmic dance. They actively shape the fate of their host galaxies. They reside at the centers of galaxies and exert a powerful gravitational influence on their surroundings. This gravitational pull can affect the orbits of stars and gas clouds, creating dynamic and often turbulent environments. As matter falls into a supermassive black hole, it forms an accretion disk, a swirling disk of gas and dust that heats up and emits intense radiation. This process is not only spectacular, but also incredibly energetic, releasing vast amounts of energy. This radiation can outshine the combined light of billions of stars, making these active galactic nuclei, or AGN, some of the most luminous objects in the universe. Quasars, a type of AGN, are so bright that they can be seen across vast cosmic distances, acting as beacons in the night sky. The energy released by AGN can influence star formation rates in their host galaxies and even shape the distribution of gas and dust on galactic scales. This feedback mechanism can either trigger new star formation or suppress it, depending on the conditions, thus playing a pivotal role in the life cycle of galaxies. Black holes also play a role in the expansion of the universe. While they do not directly contribute to the accelerating expansion attributed to dark energy, their gravity affects the distribution of matter and energy on large scales. The gravitational pull of black holes can slow down the expansion of the universe locally. However, on larger scales, the repulsive force of dark energy dominates, leading to the observed accelerated expansion. Black holes are natural laboratories for testing the limits of our understanding of physics. They provide extreme environments where gravity is at its strongest, and the laws of physics are pushed to their breaking point. Studying black holes can help us answer fundamental questions about the nature of gravity, the behavior of matter at extreme densities, and the evolution of the universe. Black holes are invisible by definition, as no light can escape their gravitational pull. However, we can detect their presence indirectly by observing their effects on their surroundings. For example, we can observe the motion of stars orbiting around a black hole, inferring the black hole's mass and location. We can also detect the radiation emitted by matter falling into a black hole, such as X-rays from accretion disks. Despite decades of research, many mysteries surrounding black holes remain unsolved. For instance, we still don't fully understand what happens to information that falls into a black hole, a puzzle known as the information paradox. We also don't know how supermassive black holes formed in the early universe or the exact nature of the singularity at the center of a black hole. Black holes continue to captivate our imagination and inspire awe and wonder. They are cosmic objects of immense power and mystery, pushing the boundaries of our understanding of the universe. As we continue to explore the cosmos, black holes will undoubtedly remain at the forefront of scientific inquiry, offering tantalizing clues about the fundamental nature of space, time, and gravity.